So welcome to the first ever 3A Water webinar. Great to see so many persons online. Yeah, so I'm Tuomo Nissinen, CEO of 3A Water. Apologies, we are starting a couple of minutes late. Bit of a technical learning here on the first webinar. But yeah, great to be here and great to see everybody here. And today's topic of this webinar is unexplained flotation variability. Is the water chemistry the missing factor? And in our webinar, we have also a guest speaker with us, Piia Suvio, who is a leading expert on metal processing and water-related processes in mining. She used to be in several different director positions in Metso and former Outotec on mineral processing development, water tailings business, and water treatment. So she has an extensive experience on water quality effect on flotation processes. But before letting her to tell her perspective on flotation and water quality, from the registration list, I see that there are many persons that might not be that familiar with the flotation. So let's first take a very brief introduction to the topic. Yes, so flotation is a common mineral processing and enrichment technique where valuable minerals are separated with air bubbles. So the mined ore is first milled to fine particles and fed to the flotation cell on a water-based slurry. And then flotation is based on the surface interactions between mineral particles, collector, reagents, and air bubble. So in principle, collector chemicals will selectively attach to the mineral particles and turn the particles hydrophobic. Then particles are attached to the air bubbles that are fed from the bottom of the flotation cell, and the mineral particles float then to the top of the cell with the bubbles, creating a froth that is collected as an enrichment. And particles without collector molecules are then going down to the bottom of the cell and eventually extracted as tailings, which mean the enrichment waste. The flotation is based on controlling mineral surface chemistry. That's why collector chemicals, mineral surface depressants, activators, and pH control reagents are used to get the optimal interaction. Dissolved metals are often used as depressants or activators to get selective separation for certain minerals. These flotation processes are tuned for the ore type and ore variability and controlled with this reagent dosing. But the water is often regarded as a stable carrier material. But now I will let the expert Piia to get on the stage and talk more about the water quality effect on the flotation.
Perfect. Thank you, Tuomo. Okay. So let's move on. Welcome on my behalf as well. I will now move to discussing why water quality is important for flotation, why does it matter more at the current time, and what kind of solutions can we have for the water quality related issues in flotation. Well, flotation is very sensitive to water chemistry. In fact, we could say water is a reagent in its own right. And why does water quality matter more now today than it did before? Well, water is getting more scarce, and there's also a huge pressure becoming more and more from the environmental, social, and governance related matters. There's higher water cost, and there's also a lack of availability of the water. Hence, we need to recycle water more. And one of the issues why we need to do it more as well is because there's discharge limits that are putting pressure on how much you can actually discharge to the environment. So hence we need to really find ways to increase the water recycling. This then leads to often closed water loops, which is really a preferred way of approaching operations. But this leads to an issue of accumulated dissolved species in the water. The more the complexity of the ores and lower grades are also creating an issue, and this is in fact the number one issue that the operations are facing today. This is leading to higher processing demands and also resulting in increased water consumption in itself. There's also increased tailings production, tailings processing and disposal. Here you can see in the picture there's a conventional tailings dam on the top, and the bottom right corner there's a tri-stack tailings stack. So this is the way tailings management is advancing at this current time. And when we are dewatering the water from the tailings, this is also raising a pressure to put the water somewhere. And oftentimes the best way is, of course, to recycle it back to the processes. Climate change is also causing an issue. So seasonality is getting bigger, so there's bigger differences between the winter and summertime, in particular in the northern hemispheres. And the extremes, for example, if you have a very dry environment, the environment will be even more drier due to the climate change. And hence the amount of water that is available for the operations is getting less. Water variability is also increasingly affecting the flotation performance. So all of the above issues are causing the water variability to increase, and hence we have an issue with the performance. Water is not just a transport medium, it is a parameter on flotation process or reagent, as I mentioned before, as we want. Well, what are the variables that matter? First of all, it's the chemistry of water that is here the issue. And what it does, it interacts with the reagents. It also affects the particle bubble attachment, as well as the froth stability and the transport of the froth. This then and all of these are impacting the flotation performance itself. Then if we look at individual water quality variables that matter the most, we have first and foremost the pH. So we have the pH window, which is often governing where the best flotation performance is in the process. Then we have certain dissolved ions that are causing issues. So these are in particularly calcium, magnesium that are hardness inducing ions, and then we have the sulfate. The amount of total dissolved solids is an issue. So these directly reduce the recovery. Then we have organics, which can cause certain issues. They can depress or coat the minerals, for example. Overall, silica and fine suspended solids that are in the water, they are consuming the reagents and also can reduce the bubble particle collision efficiency. Then we have the temperature. So this is affecting the reaction kinetics, and temperature is particularly important with sulfide ores because that can lead to the change in the pH, and that can then, of course, again alter the pH window. So temperature in some cases can be a very huge issue. We have a bit of a case study here. That this is Boliden and Kevitsa data. Boliden and Kevitsa is maybe the most studied in terms of the impact of water quality in flotation, at least in Finland, but I would say probably in the wider world picture as well. Boliden and Kevitsa, it's an open pit mine. It's located in the northern Finland. We have a low sulfide mafic ore, and they are using sequential copper-nickel flotation. And what they did in 2012, they decided to start to recycle the process water through the tailing storage facility. And you can see here on the right what happened when they closed the loop, so to speak. So the conductivity of water started to alter between different seasons. So going to the spring towards the warmer months, the conductivity is increasing and then it starts to decrease again, but with a delay going to the winter months. So here we can see that the impact of water quality carries over further from the period where it occurs in effect. And what they discovered is that they had problems with both the grade and the recovery during these warmer months. And the impact of the high conductivity that started to increase in the spring was really seen in the summertime even more. Okay, let's look at the EH-pH diagram a little bit in here. So here is the good nickel recovery as they found in Kevitsa. It's a quite small window that the EH-pH has to be in order to get a good nickel recovery. Well, what they discovered in the warmer months that there was a decrease in both the pH and the EH, so the redox potential in the nickel flotation feed. And once they investigated this a little bit further, what they realized is that the long residence time in the tailings storage facility, so this is a tailings dam, it allows various reactions to occur in the water. And then this is a sulfide ore, so the higher T is the temperature increased the kinetics of this dissolved species, so the kinetics of the dissolved species oxidation, and this was resulting in a mine drainage, which is a very low pH acidic phenomenon. And the oxidation of sulfur species then lead to this pH drop. So now what can we do? So I'm not going deeper into the Kevitsa, but what I can say is that there was a major drop in the recovery during the warmer months. And this is something that they have been trying to work on very intensively on, and I believe with good results as well. So very good on them. Now I'm moving straight into the solution, giving you first a bit of an idea of how the issue is and what can happen, and indeed what the quality constituents are that are causing the issue in flotation. Okay, what can your solution look like? I would say prioritize your actions. So if we start to look at different ores and the behavior of the froth and trying to understand all around what in the water is causing issues, we have to look at every different ore separately. We have to look at every production, every location of the site, and it becomes a huge matrix where almost every site has a different recommendation on what to do. But what I'd like to see is more general recommendations on what to do. And the first one is really use good quality of water in general. So look at your waters, do some water management activities, look at where do you have good enough quality water, where is it poor, and decide accordingly where to use the water. Here I have an example on copper sulfide flotation. So what we have here is good quality water, moderate quality water, and poor quality water. And what we can see in the beginning, once you start the operations with these different kind of waters, there is not that big of a difference in the recovery. But once the operations continue, the impact of the bad quality water becomes extremely severe. And you can see a major drop over time in the recovery. So that is also giving a bit of a, let's say, difficult way, or it's leading to a difficult way of actually monitoring what happens, because in the beginning you're thinking, okay, well, there is not a huge issue here, but over time you start to understand that the recovery is dramatically dropping. So overall, good quality water is really the starting point. Number two, what I would say, you have to remove the suspended solids. These are causing major impact, as was explained before. If you don't measure, you can't manage. So what one really need to do is use DG product measurement technologies and tools to measure the important variables. For example, the EH, well, pH, of course, dissolved oxygen levels, conductivity, and the temperature, which matters in some cases more than others, as explained. The pH should really be managed first. Then improve the dissolved oxygen control. This is really important, as well as the residual reagents. So once the reagent amount starts to accumulate in the system, they will cause a drop in the recovery. And if I have to mention one species of impurities in particular on its own, it's the iron. So iron chemistry is important because iron often dominates the flotation EH behavior, the redox behavior. And Tuomo will come to this, how you can work here with iron a little bit later. One slide later, because this is my last slide. So outcome. What happens when you have a high performing flotation circuit and concentrator with good quality water? You have higher recovery and grade, both of them, not just recovery, but also the grade. You have less loss to tailings in terms of the product. You have better process control, optimized reagent use, so you're also not losing in OPEX through the reagent. You have sustainable operations, which then means you have improved image as an operations, and also least but not the least importantly, maybe the most important, improved profitability. So the focus on water really matters if you want to have sustainable, less risky and profitable operations. Over to you, Tuomo.
Yeah, thanks, Piia, on this very interesting talk about the water quality overall. Let's go now a bit more on the dissolved metal part of this. So the dissolved metals are often the blind spot in many industrial operations, since they are only routinely analyzed in the labs and results are then arriving hours or maybe days later, depending on the logistics. So there is no operational information about the dissolved metals, for example, iron, in the process waters, even though these dissolved metals can accumulate on recycled waters and they can vary for many reasons, like Piia explained, weather conditions, seasonal changes due to ore variability. And these dissolved metals can affect on the flotation selectivity and recovery in many ways, also by activating or depressing the mineral surfaces. So this is an uncontrollable variable in the process without the visibility on it, and can be a source of the recovery or selectivity issues. So the water solution for this is called multi-metal water analysis system that allows the monitoring of metal levels and the decision making based on this information, all in 15 minutes. We want to bring the lab water quality information to the hands of the process teams. So first, you measure with our solution frequently to see if unwanted dissolved metals have an effect to the flotation chemistry, and then to understand what parameter is causing the instability in the process. And finally, to resolve the issues by selecting and mixing the waters properly or inducing new water treatment to get rid of these dissolved metals that are causing issues in the process. So here is our product and how the solution actually looks itself. So it's a portable, fast and easy to use system to analyze 11 different dissolved metals species in an industrial conditions. And we can go down to micrograms per liter or ppb level. You can check more technical information from the web pages reagent.com or get on this QR code for the details. One example case that we have been working with our customer here. So they had the challenge that the seasonal changes are affecting to the reservoir and process water quality that's used in the flotation process, and that induced significant production losses. They have started to use our system, and the fast water quality data helped them first to study the impact of the water quality to the enrichment process, and as a result that led to a decision on building a new water treatment step that will get rid of these water quality problems and the dissolved metals. In this case, that was an iron, as discussed earlier, what's in a quite typical example. Finally, want to say here that we are looking for concentrators as pilot partners where the flotation performance varies due to the water quality and dissolved metal reasons or without clear explanation. So our pilot approach is a three-phased project. We first plan the monitoring and define the KPI related to flotation where we compare the water quality. Then system is validated, hardware delivered, users trained, and routines established on the site. And then is the independent use phase at the customer site. And finally, we compare the water quality against the selected KPI and identify if dissolved metals are a meaningful variable in your process and estimate the value together with the client for the real-time dissolved metal information and what actions it can create for the process and how it can help you. So that's all what I wanted to say on our solution. Now there is a bit of time for questions and answers. So please, if you have any questions, you can write those on the chat box and also put there who the question is targeted for, me or Piia. Thank you. Yeah, just got a question or comment that they'd like to receive more information on this analyzer. That will be done after the meeting. Any other question? Another same post. That's great to hear. Any technical questions for Piia? She said that's a great opportunity here that we have a world-class expert on the flotation to ask. Yeah, now there is a couple of questions, so I can read those and maybe these are probably for you, Piia. When you do reuse the water, do you calculate the cycle of concentrations of unwanted ions?
Right. So there's few ways of predicting. You can't fully calculate, but you can predict the concentration of the unwanted ions when you start to close the loops. First of all, you can simulate them. So there's some simulation tools that are capable of doing a dynamic modeling, if you may, where you are looking into the future of when you start to recycle the water, which are the impurities that start to accumulate. So that's one way. Then there's if you are starting, so you're greenfield, so you can do the locked cycle test, which is something that some testing facilities and technology suppliers that they have available. And in that locked cycle test, you're running the cycles and recycling the water through the cycle. So you start to see how the impurities are accumulating. And also on those tests, it's possible to compare the impact of the processed water impurity concentration increase to a certain good quality water. So you see the difference on how much it will be, and then you can predict the future. You can also do, for example, leaching tests. So if you only have the ore at the time, you can do leaching tests, and then you start to get an idea what is leaching out of the ore. Of course, the tailings setup, so do you have a tailings dam or are you actually processing your tailings, will have an impact because, of course, when the water is in contact with the tailings, there will be some impurities that are leaching out of the tailings to the water. So shorter the cycles, less there is leaching out of the actual tailings, but then you have different impurities. So you have to understand really how to balance those. So it's a bit of prediction and some literature and some test work that I would recommend there. Okay,
Yeah.
now we have a lot more questions.
Yeah. I think next one is more for me. such a device is typically used in the mining setup. What about metallurgical plants where to control discharge waters? Yeah, this is good another example, and we are already working with the customers like Aurubis, Hamburg, copper smelter on that type of case. So we are working on the internal water quality in the mines and also for the metal processing, more related to discharges often. Then there was a question about metals, what we can analyze. So here in the slide is the list of the metals. We are still working on adding few metals here. The current work is concentrated on the chromium analysis, and also vanadium is already proved to work on the system. So those will be added, and the vanadium, chromium is very interesting for the steel industries, and we can separate the chromium 3 and chromium 6 species. Then I think there is a question for Piia. Do dissolved metals pose a significant problem in the plants that use autogenous grinding?
Yes, so in terms of the grinding, the water does have an impact already. So water can impact the surface kinetics in overall in grinding. Autogenous grinding, unfortunately, I don't know exactly what the technology looks like. But in general, in grinding, yes, metals can cause an issue. So oxidation, surface kinetics, or redox.
Yeah, then there is a question about silver flotation process, where they recover silver from roasted material, superhot acid leaching underflow. Can temperature affect to this process? Starts to be pretty specific.
Hold on.
Can you be up? Do you have
yeah, I'm with it. Yes. So what I would do, I would want to understand the pH window there, so that we understand, and if it's a sulfide ore, the temperature has a more of an impact. So I don't know if there's a sulfur present in the material that you're using, but if there is, yeah, temperature is gonna increase the leaching. So temperature in overall, it's impacting the leaching, more solubility, more leaching behavior in higher temperatures. So yeah, overall I'd say yes, but more with the sulfuric ores, sulfide ores.
Yeah, then another question about the temperature. What about the countries where the temperature is more stable? Does this solution have a more subtle or less impactful effect? If just considering the dissolved metals, I think that depends a lot on the other aspects also than just the temperature. Temperature can be one parameter that affects to dissolution of different species, but there are a lot of other aspects also related to this. So the stable temperature, if that's high, can make the dissolution even worse for all of the seasons, not just during the summer like here in the Nordics.
But if there is iron in the ore and temperature is the affecting, so that leaches out, then yeah, then you would have a more of an impact. Relatively stable, yeah, well then obviously the leaching impact is what it is with that temperature, is not going to be causing pikes or you know, like higher levels of iron at certain seasons more than others if it's more stable. So then iron is it's either an issue or isn't in that temperature.
Yeah, so I guess it's a bit more controllable than
yes
than in very changing conditions.
Absolutely.
Yeah, then got a comment from some metals. Lead is already on the list of analyzed, and there's also a comment on cadmium and mercury. Yeah, those are interesting. We are looking into them, especially cadmium, and there's also a question about anions analysis. Is it possible? So we are working on a certain anions like arsenic that creates oxyanion species in the water. But there is also a question about the spectroscopy, what this uses. So we are utilizing X-ray fluorescence analyzer, so it's not sensitive for the light elements, and that's why the typical anions that we might talk about here, like sulfates and nitrates, they are not good to be analyzed with the system. Then a question if this is a automated sampler. No, it's a portable system for the analysis. Is the device able to contribute to smart water recovery system? Have to admit that I'm not very sure what's the smart water recovery system term means. Do you know it?
No, it's not familiar term to me either, but no, unfortunately I don't know that term.
Probably more data can often help on the water recovery to select what waters are better or worse.
I guess what they could be aiming at as well is that can it be used with lockers so that the data is locked and then to the cloud, for example, and then used later.
Yeah.
What else do we have?
Yeah, do we have any?
There's a correction on it's not a sulfide, or it should be sulfate. I guess it's a concentrate if it's processed this concentrate in the froth, but yeah.
Okay, but yeah, thanks for all of the questions, and yeah, we had 42 viewers for this first webinar, so I take that as a great success. So thanks for all joining the webinar, and special thanks to Piia taking the time and give your expertise for us here. So the webinar is recorded and will be sent to all of the participants and all the registered people also, and you can find this also later on published in our webpage. So thank you all for joining, and let's continue the discussion later. So still, here is my contact information. You can find them here, and you can find from LinkedIn Piia Suvio from there, and contact her directly, or you can contact her also through me.
Yes.
Somebody asked still for the slides, so yes, we can also deliver the slides for the accompanying the link for the video. So great. Thank you all for joining, and we will have another webinar coming still, so stay tuned for the news on the next webinar. Great. All right, thank you all.